Executive functions. The path from problem to solution is rarely straightforward. Along the way, there are time-wasting distractions to resist, dead-end strategies that need to be abandoned in favor of better ones, and unforeseen obstacles that demand a new plan. There is effort associated with this approach, as the easiest option would be to give in to temptation, to repeat what has been done before, and only to consider one thing at a time. However, the benefit of being flexible, controlled, and focused is behavior that is much more likely to achieve the end goal. The collection of cognitive skills that keep goal-directed behavior on track are known as executive functions, and they offer just-in-time solutions to questions like where should I focus my attention next? What action do I need to inhibit? And what information do I need to update? Ibbotson 2023. At a general level, these skills can be organized into three functions. Inhibitory control allows us to block irrelevant actions or thoughts and keep us focused on the goal. For example, resisting eating one marshmallow now for the promise of two later. Working memory describes the ability to mentally work on multiple sources of information at the same time. For example, remembering the directions of how to get somewhere while also remembering the destination. Cognitive flexibility allows us to suddenly change perspectives or switch tasks. For example, talking in one language, then talking in a different one, then switching back to the first. Executive functions represent a collection of skills that enable us to be flexible, controlled, and focused. Throughout our explanation of childhood, we have made many references to executive functions. This is because they underpin such a wide range of developmental outcomes for children, some of which we have already explored. In the context of working memory development, Chapter 10, Inhibitory Control provides another example. One study found that children who are better at waiting their turn, less easily distracted, more persistent, and less impulsive, were more law-abiding and have better educations, higher salaries, and more favourable mental and physical health when they are followed up 30 years later, even after taking into account differences in intelligence, sex, social class, and family circumstances. Moffat et al. 2011. The ability to adopt long-term strategies, and resist immediate gratification continues to develop across adolescence. Experimental evidence suggests that the abilities to reason about gains and losses, balance and emotional consequences of reward and punishment, and self-regulate behavior with others are still developing into early adulthood. Holzinger et al. 2007. More generally, the development of executive function is influenced by the age-related changes in other areas such as emotion, regulation, and social competence, which interact with each other in non-linear ways, e.g., showing up in U-shaped curves. Precisely what children and adolescents find difficult to resist is influenced by what their culture values, something that will be explored in greater depth in Chapter 15. The ability to effectively switch between tasks using cognitive flexibility also takes a long time to develop compared with other cognitive functions like language and memory. For example, children as young as 3 years of age show some degree of cognitive flexibility and have no difficulty sorting objects by either colour or shape. Kirkham et al. 2003. But when they are asked to switch the sorting criteria halfway through the task, from colour to shape, or vice versa, they struggle to adapt the new rule and stick with the old one, even though they know what they should do. In this respect, young children perform similarly to adults who have experienced damage to the prefrontal cortex, an area of the brain we know is associated with executive function. Crone, 2009. By 4 to 5 years of age, most children have significantly improved on these tests, but it is not until 7 to 9 years of age that they've switched flexibility at a trial-by-trial basis, with further age-related improvements in mental flexibility seen in adolescence. Crone et al. 2006, Gupta et al. 2009. Speaking to just how protracted the acquisition of cognitive flexibility is, the cognitive cost of changing tasks persists in adulthood, as indicated by greater response times for switch trials, regardless of whether adults are informed of the upcoming switch or whether there is a gap between trials. Diamond and Kirkham, 2005. Interestingly, when adolescents fail to perform like adults on tests of executive function, it might not always be that they simply cannot do the task. Rather, their brain's reward system are set at a higher threshold, e.g. dopamine levels, see section 13.3. So they might need the stakes to be higher, the tests to be more arousing, and social consequences to be more real to motivate their executive functions in action. Crone, 2009. Key point: executive functions are associated with a wide range of outcomes for children and take a long time to mature. People from Marquesas Island in Polynesia say that someone has reached adulthood when they have outgrown their turuaro, which means they are now reliable, hardworking, and able to control their impulses. Similarly, the Arabic word ak refers to the ability to make rational, informed decisions and to control one's impulses and passions. People who have not obtained ak are not adults yet, and Arabic cultures is believed that females generally develop ak at an earlier age. There is some evidence to back this up. While adolescent boys and girls perform similarly on most tests of executive function, there is evidence that inhibitory control matures earlier in girls compared to boys. This is underpinned by an earlier development of brain areas associated with the function, which may relate to sex difference in the timing of puberty. Lenroot et al. 2007. At the behavioral level, this means that boys are likely to be more impulsive than girls of a similar age. Experimentally, this has been demonstrated in the ways boys and girls balance speed and accuracy in a task that requires some inhibitory control to succeed. On average, boys are quicker to respond, but girls give more correct responses. Ibbotson and Rogue Gutierrez, 2023. Out of the lab, inhibitory control is clearly important in the context of risk-taking. Resisting an inappropriate behavior, e.g. running a red light, requires effortful control, and if girls' inhibitory controls matures earlier than boys, then this is another significant factor affecting the risk-taking behavior of adolescents. There is some evidence to suggest that inhibitory control emerges earlier for girls than boys, underpinned by early maturation of the brain areas that support this function. Talking point: what do you do if they're trying to set the insurance premiums for adolescent drivers? Empirically, it's true that adolescents as a group are overrepresented in car crashes compared to other groups, especially when they are accompanied by peers. But it is morally right to impose the statistics of the group on an individual teenager who might be the safest driver ever to get behind the wheel. In December 2012, the European Union introduced controversial new rules. insisting that car insurance companies no longer discriminate on the basis of sex. Prior to this, women enjoyed lower premiums as they were known to be safer drivers with lower accident rates. Contrary to expectations, the sex difference in premiums actually increased after the law was introduced. Insurance companies no longer use sex to directly set premiums, which would have been illegal, but instead used a host of other personal data such as occupation, which is closely related to sex. Scaffolders can more likely to be men than women, while midwives are more likely to be women than men. Therefore, midwives are more likely to drive fewer miles and have fewer accidents. The accidents they do have are less serious, and the cars they drive are cheaper and to repair. Is a similar law in the pipeline for adolescent drivers, and that counts as quality in such cases. Whatever the physiological physiological and legal outcomes of such debates, the science of adolescence can continue to improve our understanding of why adolescents make the decisions they do. Summary. Adolescents have a fewer mortality rate than those in most other stages of life, but they are more likely to be accidentally injured and to engage in risky behaviour, and they are poorer at judging the long-term consequences of their actions. Novelty and sensation-seeking behaviours with greater risk-taking and peer influence. Adolescents than those that keep impulses in check and that deliberate over alternative choices. Knowing or believing that peers are observing their behavior significantly increases the risk-taking behavior of adolescents, even in absence of any direct peer pressure. The behavior of early adolescence is strongly guided by the social environment, both for positive and negative outcomes. Sex differences in mortality and risk-taking persist within similar societies, between different societies, and across a wide variety of species and environments. Are seen in wide range of species on the cusp of adulthood, suggesting a shared evolutionary explanation. Adolescence is a time of investing in peer relationships, heightened sensitivity to group identity and emotional intensity. The reward system of the brain mature early and are more well connected in life. History theory predicts that boys are more willing to engage in risky behavior in same-sex competitive contexts. Executive functions represent a collection of skills that enable us to be flexible, controlled, and focused. Executive functions are associated with a wide range of outcomes for children and take a long time to mature. There is some evidence to suggest that inhibitory control emerges early for girls than boys, underpinned by earlier maturation of the brain areas that support this function.